Okay, so now let's talk about systems of equations that don't have unique solutions. So sometimes while you're solving a system, you might eliminate all variables and end up with a statement like, let's say 0 equals 5. So this is clearly not true. It tells us that the system is inconsistent. That is, there's no solution. The equation contradict each other. On the other hand, if you end up with something like 0 equals 0, so this is always true. It means that the system is dependent. So this happens when all the equations describe the same geometric object. For example, the same plane in 3D space. So in a dependent system, there are infinitely many solutions because all the equations overlap. So in summary, so if you get 0 equals to any non-zero number, that means your system is inconsistent and you cannot solve it. There's no solution. But if you end up with 0 equals 0, the system is dependent. In that case, you have infinitely many solutions. So let's try to see some examples like this. Okay, so let's start with here. So you have to solve this system of equation. So again, this system is not in triangular form. You have to do some reformulation to get this triangular form, and you have to solve this. So let's start. So the first equation, the coefficient of x is 1, so that is good. So now we have to go here and you have to eliminate x variables on the second and third equation. So to do that, what you have to do is, first of all, you are going to take the first equation and you're going to multiply it by -3 and you're going to add it into the second equation, and you're going to replace the second equation by the resulting equation. So let's multiply the values. So the first equation is going to be like -3x plus 3y negative 12z equals 15, because you multiplied first equation by -3. So you have to add the second equation. So second equation, it doesn't have a y variable, but it is something like this. So if you add this together, you'll get 3y minus 11z equals 15. So now you're going to go ahead and replace your second equation with this new equation. So x minus y plus 4z equals -5, and the second equation is going to be 3y 11z equals 15, and third equation, it's going to stay as same because we didn't do anything for that. Okay, so now let's move ahead and remove this x from the third equation. To do that, you're going to take your first equation and you can multiply it by +1 and you can add it into the first equation. So you're going to take your first equation, multiply it by -1 and you're going to add it into the third, and you're going to replace the third equation. So this is how you do the simplification. X minus y 4z equals -5. So this is the first equation, multiplying it by, okay, here this is a mistake. So you have to multiply the first equation by +1. So that means it's just the same equation. And it's going to be now, the third equation is -x plus y minus 4z equals 20. So you have to add this together. So if you add this, positive x and negative x, they cancel out. These two also seems to cancel out. Okay, this is interesting. And these two also cancels out. So it's going to be 0 equals 15. So let's take my system and I'm going to replace the third equation by my new equation. So here, the third equation, it's going to be 0 equals 15. So 0 cannot be equals to 15. So this is impossible. So that means this system is inconsistent and has no solution. So you cannot solve a system like this. So this system is inconsistent. and has no solution. Okay, so in order to see whether there's a solution or not, you have to do the simplification. But if you end up with something like this, which is impossible, you can conclude the system is inconsistent. Okay, moving on to the next example. Again, we have a system of equation. You have to solve this. We'll do the simplification. Okay, so here in this system, I have my first equation, but in my first equation, I don't have a positive coefficient for x, a 1. So what I can do is, I can, if you want, you can interchange it with the second equation, but I'll do this in a different way. What I can do is, I can make the coefficient of x a positive just by multiply each term of this equation by -1. So let me do that. So I'm going to multiply the first equation by -1. So it's going to be x negative y negative 2z equals 0. So second equation, it's going to be x 2y plus z equals 6. Third equation, negative 2x minus 2y plus c equals negative 6. So here this method also, it's kind of easy. I'm not going to change this. It's just I took the first equation, I made the coefficient of x as 1. Okay, moving forward, now I need to get rid of this x's in the second and third equation. To do that, what I can do is, I'm gonna take my first equation and I'm gonna multiply it by -1, and I'm gonna add it into the second equation and replace the second equation. Okay, so here first of all, you have to multiply the first equation by negative. So it's going to be negative x, negative y, a positive y plus 2z equals 0, and you write your first equation, the second equation, and you add them together. So this will give you a 3y, and over here you'll get a 3z equals 6. So now your second equation you have to replace. So I'm going to copy the second equation. I'm going to copy the whole system, and I'm going to change my second equation as 3y plus 3z equals 6. Okay, so now I have no x in the second equation. To do the same to the third equation, I'm going to multiply first equation by 2, and I'm going to add it into the third equation, and finally I'm going to replace it. Okay, to do that, I'll get 2x negative 2y negative 4z equals 0. And over here, 2x minus y plus z equals 0. And the x's will cancel out. Here you will have 3y minus 3z equals, okay, here it's going to be negative 6. So this is going to be a negative 6. So now let's copy this. Now I'm going to paste it over here, but I'm going to update my third equation, which is negative 3y negative 3z equals negative 6. Okay, this is good. So now what I can do is, I need to make the coefficient of y as 1 in the second equation. To do that, I'm going to divide each term by y. Okay, I'm going to copy this down. Okay, and to make the coefficient of y as 1 in the second equation, if you divide the first equation by 3, you get a 1, and here also you get a 1, but over here it's a 2. Okay, so now moving forward, we need to remove y in the third equation. To do that, you take your second equation and you multiply it by 3, and you add it into the third equation, and you replace the third equation. So if you do that, the second equation by 3 gives you 3y plus 3z equals 6, And the third equation is negative 3y minus 3z equals negative 6. Okay, so if you do the addition, okay, it seems like you get 0 equals 0. So now you take your system of equation and you replace your third equation. So this third equation is going to be now 0 equals 0. So here this equation has infinitely many solutions. So this system of equation has infinitely many solutions. For example, if you take z equals any number, you can take any number, then the value of y will be equals to 2 minus z, and the value of x equals 2 plus c.